Could the Andromeda galaxy be home to star-encasing megastructures built by alien civilizations? What if some of the stars in this distant galaxy were not just burning furnaces of nuclear fusion, but the engines of something much more sophisticated, something artificial? For decades, we've theorized about such megastructures, Dyson spheres, giant constructs designed to harness the total energy output of a star. But why haven't we found one? With all our technology and knowledge of the universe, why are we still searching for signs of intelligent life, only to come up empty-handed? Could the answer be hidden in the heart of Andromeda? Or is it simply the product of our imagination? In this investigation, we'll uncover the truth behind one of the most tantalizing mysteries of modern astrophysics. Could Dyson spheres exist in Andromeda, and what would their discovery mean for us? In 1960, Freeman Dyson proposed one of the boldest ideas in the history of science, the Dyson sphere. Dyson, a theoretical physicist, speculated that any sufficiently advanced civilization would need to harness the energy output of its star to meet its growing energy demands. His idea was revolutionary. The concept was simple: a vast star-encasing shell that would capture almost all the energy emitted by a star, potentially supporting the technological and biological needs of an advanced society. But Dyson's original idea didn't exactly match what we now think of when we picture a Dyson sphere. What he envisioned was actually more akin to a Dyson swarm, a collection of independent satellites orbiting the star, capturing its energy from different angles. This swarm would replicate the efficiency of a full sphere, but without the monumental engineering challenges that a complete sphere would pose. The main question Dyson raised was, why would any civilization go to the trouble of building such a megastructure? The answer is straightforward: energy. As a civilization grows, its energy demands increase. Eventually, it would need to harness more energy than a single planet or even a star could provide. A Dyson sphere offers a way for such a civilization to capture the vast energy output of a star, perhaps even enough to fuel planetary-scale industry, interstellar travel, and artificial habitats. This idea fits into a concept known as the Kardashev Scale, a method used by scientists to classify civilizations based on their ability to harness energy. A Type I civilization can capture all the energy available on its home planet. A Type II civilization harnesses the full energy of its star, think Dyson sphere, and a Type III civilization controls energy on the scale of an entire galaxy. Building a Dyson sphere is one way for a civilization to make the leap from Type I to Type II.So. How do we detect a Dyson sphere in the vastness of space? The key lies in infrared radiation. A Dyson sphere would not only capture energy from the star, but also release waste heat. Just as a car engine emits heat after burning fuel, a Dyson sphere would radiate heat, but this heat would be in the infrared spectrum, far beyond what our eyes can see. This infrared radiation is what astronomers would look for when searching for Dyson spheres. It's a unique fingerprint that sets artificial megastructures apart from natural phenomena. If we detect unusual infrared signals coming from a star or galaxy, it could indicate the presence of a Dyson sphere. The challenge, however, is that there are natural sources of infrared radiation that can mimic this signature. Dust clouds, young stars, and even gas around black holes can also produce infrared emissions that resemble the heat signature of a Dyson sphere. But Dyson's idea was compelling because it suggested that the heat emitted by a Dyson sphere would differ from natural sources in key ways. For example, a Dyson sphere's waste heat would likely be distributed evenly across the infrared spectrum, whereas dust clouds and young stars might emit heat in irregular patterns. If we could find a source of infrared radiation that didn't match any natural explanation, we might be looking at something artificial, the Andromeda galaxy, our nearest galactic neighbor, contains over 1 trillion stars, making it the perfect place to look for alien megastructures. In 2009, NASA launched the Wide-Field Infrared Survey Explorer WISE, a space telescope designed to scan the universe in infrared wavelengths. One of its primary goals was to look for the kind of infrared excess that could indicate the presence of Dyson spheres. WISE surveyed galaxies, stars, and nebulae across the entire sky, capturing vast amounts of data. In its search, WISE turned up some unexpected results in Andromeda. Some stars in the galaxy were emitting more infrared radiation than they should have, given their observed characteristics. These stars didn't fit the usual models for stellar evolution or behavior, and their excess infrared emissions were unusual enough to raise suspicion, the idea that some of these stars could be hiding Dyson spheres' massive artificial structures. Absorbing and radiating energy began to take hold. Some scientists flagged these stars as potential candidates for the existence of megastructures. The infrared excess coming from them wasn't easily explained by natural causes, and that made them intriguing targets for further investigation. However, even with these intriguing findings, the road to discovering a Dyson sphere is far from straightforward. The universe is full of phenomena that can produce infrared emissions that look similar to the signature of an artificial megastructure. Dust disks around young stars, for example, can emit infrared radiation as the dust absorbs, and ray emits starlight. Similarly, large clouds of gas can give off heat that mimics the signature of a Dyson sphere. This means that while the infrared excesses detected in Andromeda are exciting, they could easily be explained by natural phenomena. The task of differentiating between natural and artificial sources of infrared radiation is incredibly difficult, especially when we consider that Andromeda contains over 1 trillion stars, many of which exhibit some form of infrared excess. Even if millions of stars exhibit similar characteristics, the challenge becomes finding the one that is truly unique, a star whose infrared signature cannot be explained by anything other than an artificial megastructure. It's a needle in a haystack problem. With so many potential natural explanations, it's easy to see why many of these discoveries don't lead to a conclusive answer. But the search continues, because in the back of every scientist's mind is the question, what if? If a Dyson sphere were discovered, it would send shockwaves through science and society. It would be the first solid evidence that an advanced extraterrestrial civilization has mastered the ability to harness the energy of a star. This would place the civilization on the Kardashev Scale as a Type II civilization, one that has completely transcended the energy limitations of its home planet. The implications would be profound. It would not just reshape our understanding of alien life, but it would also raise questions about the future of our own civilization. Could humanity eventually build such a structure? Would we too, one day, need a Dyson sphere to meet our growing energy demands? And what could we learn from such a civilization's technology, possibly unlocking the secrets of interstellar travel or energy manipulation? But beyond the technological impact, a discovery of a Dyson sphere would have deep philosophical consequences. It would force us to reconsider our place in the universe. Are we truly alone, or are we just one of many civilizations across the cosmos that have risen, fallen, and evolved? A Dyson sphere would suggest that intelligent life might be far more common than we ever imagined. Of course, not every unexplained infrared signal is proof of alien technology. Some scientists have proposed alternative explanations that could account for the infrared emissions we've detected. For example, black holes could be harnessed as power sources. Some advanced civilizations might build structures around black holes to extract energy from them. This process, known as the Penrose process, involves extracting energy from a rotating black hole's accretion disk. Such a structure would emit infrared radiation that could mimic the signature of a Dyson sphere. Another possibility is that dark matter, an elusive substance that makes up most of the mass in the universe, could be used to harvest energy. Advanced civilizations might manipulate dark matter in ways we don't yet understand, producing energy signatures that resemble those of Dyson spheres. These alternatives, while speculative, highlight how much we still have to learn about the universe and the potential for different kinds of energy harvesting. The idea that we might be looking at something even more exotic than a Dyson sphere is a tantalizing possibility. The search for Dyson spheres, and for any sign of advanced extraterrestrial civilizations, is not over. In fact, the next generation of telescopes, particularly the James Webb Space Telescope, will significantly enhance our ability to detect these megastructures. Webb, launched in 2021, is designed to observe the universe in infrared wavelengths with unprecedented precision. With its ability to detect faint infrared signatures across vast distances, Webb will give scientists the tools they need to revisit the anomalies detected by WISE. The hope is that with Webb's superior resolution and sensitivity, we can definitively identify any artificial signatures coming from stars in Andromeda and beyond. By focusing on the specific stars that exhibited strange infrared emissions, Webb could help us determine whether these anomalies are truly the result of Dyson spheres or if they have natural causes. Additionally, machine learning and artificial intelligence are playing an increasingly important role in the search. AI algorithms can sift through enormous amounts of data, identifying subtle patterns that human eyes might miss. This could be the breakthrough we need to finally find that elusive megastructure, hidden somewhere in the vastness of space. The search for Dyson spheres is a long-term endeavor. It's a search that requires patience, perseverance, and an open mind. Even if we don't find any megastructures in our lifetimes, every failure to detect one brings us closer to understanding what we're truly looking for. Each new observation refines our search methods, helping us separate the natural from the artificial, the explainable from the mysterious. The quest also raises an important ethical question. If we were to find evidence of a Dyson sphere, should we reveal our existence to the civilization responsible? Would they be aware of us, or might they be watching our planet, waiting for us to make the first move? These are questions we'll have to grapple with as our search for extraterrestrial intelligence continues. If Andromeda hides no Dyson spheres, does that make humanity's potential more unique or more fragile? Are we truly alone, or are we just on the cusp of a discovery that will change everything we know about life in the universe? The search continues, and the answer could lie just around the corner or in a distant galaxy, waiting to be uncovered. And if you enjoyed the video, consider leaving a like and subscribing. Thanks for watching.